Rabat. It is a great pleasure for me to welcome you to this first session, and it's a pleasure to introduce our keynote speaker, Professor Cohen. After receiving PhD from Brown University in 1983, Dr. Cohen served in the Department of Electrical Engineering at Rhode Island. He received the Research Excellence Award from the College of Engineering at Rhode Island in 1985. He joined Drexel University and currently serves as director of the ECE department, Imaging and Computer Vision Center. In 2003, he received the Thomas More Teaching Award. Today, Dr. Cohen will present a talk entitled The Need for Cultural Machine Translation, Challenges and Solutions. I give the floor to our keynote speaker, Dr. Cohen.
Thank you. And to be here to share with you our work on cultural translation and maybe shed lights as to why it is an important topic to be considered. At least, as the late Edward Said would say, to understand the other. And translation is a very important part of that. So, with that, let me start by asking two questions. The first is, what is cultural translation and why is it important? And what happens when it is not applied? The first question is translation basically a literal translation of one word to another? And of course the answer would be no, but let me ask the second question. And the second question will be, what happens if the space between the translators and the translated is not grounding in a good understanding of the culture of the translated? So for the first answer, it will be, of course, it isn't a word-by-word translation. It is a really challenging journey in trying to understand the nuances of what is said or written. So it is not you open the dictionary, you find the equivalent word, and here you go. You have to read the subtext. And in particular, what the culture subtext is, to be able to convey it to a foreign audience where the translation of the work is going to be read or heard. And for the second question, basically, if you do not really abide by the cultural translation and a good understanding of it, what will happen is that you are going to be more conveying the biases of what the foreign language or the foreign audience is having of the other, rather than being embedded in the cultural translation of the place itself. So, for instance, if I were to, since I'm in Morocco, if I were to translate Khubz al-Hafi, I would try to understand, it is not translating sexual abuse of children, but rather you have to understand what it means in the Moroccan culture before I go and translate it into a US culture, which will look at everything in terms of an abusive lens. So that is very important, and that's why cultural translation should play a very important role. So what is the biggest challenges that not only machine translators do encounter, but even human translators? The biggest challenge is basically the ability to understand the cultural nuance of what is written or spoken, And why is it difficult? The main difficulty stems from the fact that there is polysemy, and polysemy is when a word will have different meaning, and not only that, when you start using words to imply different things, and hence, when you go and just translate them as you think it should be instead of the layers of what it means, you run into a problem. And what are the sources of polysemy? There are a few. There is definitely slang. If I say something in Egyptian Arabic, or if a Moroccan says, it's very, very different. Although the Moroccan will understand the Egyptian, but not vice versa most of the time, unfortunately. So there is slang. There is also misinterpretation of a word. Oh, did I go somewhere else? No, I'm still here. And there is also the culture. The culture plays an important role in this sense of polysemy. So there is dialect, cultural hegemony, stereotyping, and more importantly, and that's something that I would like to re-emphasize, is the biases that one has. Meaning, again, quoting Edward Said, if I look at how the Orient has been portrayed in the West, they're very, very stereotypical. And hence, when I get a work that I'm translating, especially if I do not understand the culture very well, the tendency is to translate it in terms of the stereotypes. So, so that there is something that needs to be addressed and be aware of. Now, so where had machine translated been a success? In simple situations, like for instance, I was visiting Portugal a few months ago, and I went into one of their cafes to order breakfast. And since I guess I look Mediterranean, hence Portuguese as well, they gave me a menu, was in Portuguese. I do not speak Portuguese, I speak other languages, but not Portuguese is not one of them. And hence what I did is they had internet, opened my iPhone, Googled it, and the things that I didn't understand what they mean, I was able to do that. So in terms of menu, in terms of maps, in terms of directions, Google Translate or machine translation is quite good. The problem becomes more challenging, complex sentence, but let's look at this one. So they said during the last night in Lisbon, they passed the port at midnight in Italy. Now, if I take this sentence verbatim and input it in Google Translate, what I get is, au cours de leur dernière nuit à Lisbonne, ils ont passé le port à minuit de Zambou. A, of course, is not the correct meaning. B, it doesn't make even sense. And the problem is that they past and the port have different meaning. And if I'm not aware of the culture, that port, for instance, is a wine, is a Portuguese wine, I will tend to say, oh, it's a port, you know, we're a harbor. And hence, the translation will be totally erroneous. So, if you do, but if on the other hand, you paraphrase the sentence, and the English sentence would be during their last night in Lisbon, they shared or handed in. So they had the wine bottle, and they give it from one person to another. And you understand that port means the wine bottle, then the translation becomes obvious. And hence, au cours de leur dernière nuit à Lisbonne, ils ont partagé la bouteille de vin port à minuit de Zambou. So now it becomes very simple and understandable. But the underpinning for doing that was to understand the culture of what it means. And this by no means is a very complicated sentence, let alone if you take the example that I gave of Khubz al-Hafi and try to translate that without that underpinning. So the important message here is that a faithful translation not only demands a comprehension of syntax, of semantics, but also knowledge of both source and target languages. So in terms of the thrust in machine translation, there are a few. And I'm going to tell you where my talk is situated with regard to those thrusts. One is word disambiguation, and by and large, there are two approaches to it. One is statistical in nature, or statistical method is used, and there is, to an extent, modeling of the dependency of words on each other, etc. And the other one is learn from examples using neural network or deep learning. There is also paraphrasing, and I gave you an example of paraphrasing that you were able to translate because you went through the paraphrasing step, and there is a lot of work along those lines. And there is also an alignment between bitexts, and that they do alignments as well as translation at the same time. In this talk, I'm going to look at word disambiguation. So this is where I am focusing now. I'm not going to talk about paraphrasing or alignments. Now, with regard to that, there are I consider three contributions and novelty of our work, and I'm going to state them one by one before I go into how we get to that. The first one is to introduce what's called a Gibbs language model, and the Gibbs language model basically embeds the multi-layer dependency between words. So I want to give an example to illustrate that very clearly. For the greatest time, until very recently, the word jalabeya, which is, in Egyptian would say galabeya, but it's jalabeya, would be translated in English, for instance, as a woman dress. So if, for instance, you have a man having their big lunch and going into their bedroom and changing into the galabeya, the interpretation in English language, a cross-dresser. Whereas, of course, that is far from the intent. If they don't know what the galabeya is, the equivalent of pajamas, and that people do wear it to go to sleep, or for that matter, they can go out in wearing the jalabeya, then you could see what happens with the translation. It's totally nonsensical. So the Gibbs model that we're coming with is basically looking at keywords. So if I look at jalabeya in somebody in the US, then my interpretation of that would be very different, unless they are of Middle Eastern origin, than would be I am in Morocco or in Cairo, and the guy is wearing a jalabeya to go to sleep. Then the interpretation will be different, and the keyword will be different. So if I look at man and jalabeya in isolation, then my translation will be erroneous. However, if I look at the context, we are in Egypt, it is siesta time, then all these keywords will give you a more likelihood of changing that translation into the equivalent of the pajama case, right? So I'll get into that when I introduce the structure of the model. The second one is what I call base learning, is how to combine knowledge given from corpora, which are parallel corpora, data-driven, as well as an expert. So if I have an expert translator, I want to combine my knowledge up to that point with the expert telling me, this is pajama, this is not, and then I will input I will update the parameters of the model. So next time I see this ambiguous word, I'll be able to deal with it without a translator being there. So the combination of translators with data-driven knowledge is very important, and I'm going to talk about that as well. And then finally, the third one is to deal with the instances where you have more than one ambiguous word in a sentence, and come up with an iterative relaxation process that will give you the most likely translation by disambiguate not just one word at a time, but all of them at the same time. And we came with a computational relaxation process to do that efficiently by fixing all the words, try to see the likelihood of changing one based on the other fixed, and then keep on iterating until convergence. I would like also to say that we're going here beyond deep learning, because what we're trying to do, in particular when we don't have too many examples to learn from, is to model. So instead of learn from examples or experience, as the neural network will do, we'll say, no. I'm going to invest in learning those dependency, those cultural dependency, before I embark into the translation. That's one. And also, what if I have limited amount of data to learn from? The neural network, it's not magical. You don't give them enough example, they're not going to do a good job. You give them more example, they'll learn more and more and more. So let me first start by talking about the Gibbs language model, what it rests upon, and how to estimate the parameter associated with the Gibbs model. Before I do that, I would like to revisit something that is used in the field of machine translation, which is the trigram model. The trigram model and the Gibbs model do share a lot of commonalities, but there are also differences. The commonality rests upon the fact that you look at the dependency of a word with other words. The trigram, by and large, how it's used today is the dependency is based on proximity rather than on keywords. Meaning, if I am in a sentence, I'm going to look at, if it's bidirectional, I'm going to look at words before the word I want to disambiguate and after, and see what are the probability based on that. Whereas in the Gibbs model, the graph is not a proximity graph, it's a semantic graph. Meaning, I can go and find keywords in a chapter or in a few paragraphs before and after to help me in zooming into the real interpretation of what the word is. That's one. Secondly, with the trigram, basically you have frequency of occurrence. So you count how many times the occurrence of a pair or a triplet, basically a pair, and there's a word, depending on trigram, will be two neighbors, bidirectional. How many times that word took the specific interpretation, and versus how many times it appeared, and you have frequency of occurrence. The Gibbs model doesn't do that. What it does is to parameterize. You have parameters that tell you how the interaction of these words in terms of clique. And the clique need not be just limited to just a clique between 3 point first neighbors. It could be triplet neighbors. It could be 4 at a time, n at a time. So you can expand, and the parameters could convey frequency of occurrence or numbers, or could be something more esoteric and complicated. But one of the commonality is that when you look at the joint likelihood of a sentence or a paragraph or a chapter or whatever you have, it is totally constructed from conditional distributions. And that is also true based on, for the Gibbs model, which means that you have, and also they exhibit a Markovinity assumption, meaning if I give you every data point, and you want to predict the the state of your word, the disambiguate, it will depend only on a finite set of neighbors. And that is the Markov property. In the Gibbs model, it is also the case, but it's a key words, not proximity words. So, if I go back to the example that I gave, the port will be, for instance, the target word, and then the neighbors you have will be Lisbon, midnight, and a pub. And the bidirectional first order will be Lisbon, midnight, and pub, and then the bidirectional second order will be the neighborhood Lisbon and pub, Lisbon and midnight, and midnight and pub. And the structure is it's an exponential, belongs to the exponential family, and these are potential functions that tells you how a word interacts with their keyword neighbors. Again, not proximity, but semantic. There is an interesting analogy between the Gibbs model and particles in physical space, a physical system, where you have particles in that system interacting with themselves and with other particles in the system, and hence this potential energy or Gibbs distribution. So it tells you, okay, the way I'm going to interact with you and you and you and you will form a particular pattern, whereas if I change the parameter, it will give me a different pattern. And that's exactly the same idea here in terms of the language model. Now, so in terms of that, we have a neighborhood, dB, and these are the neighbors. V and W is in the neighborhood, and these will be, the V and W will be keywords, and I want to judge about the state of the target word XR. If you want to make a relationship between the trigram and the Gibbs, then if I take the potential to be the parameter KV, which will basically tell you how many times this combination occurred, and if I want to look at the trigram, when I have three dependency on three clique or three neighbors, then I have another parameter, theta K, V, and W. Then if I were to go back and estimate the parameter theta, the best way to do it is doing maximum likelihood estimation, since it's going to give you efficient estimators that will attend the Cramer bound, which is the lowest bound you can get for a minimum variance unbiased estimator. Then the estimate of these parameters would be the log of the frequency of occurrence. So here you can see the relationship between the trigram distribution, parameter distribution, and those parameters that I'm going to do with the Gibbs model. So there is a connection, but I could have made the theta, this potential function, more esoteric and not just not linear in the parameter, but could be a nonlinear polynomial function of the parameter. Also, because I can get the frequency of occurrences, I can do a ranking as to who will be my first neighbor, the one that will have the highest probability. The second neighbors will be the second ones that have the second highest probability, etc. I can also determine when do I stop? Do I have to keep on going, or should I consider a finite set of neighbors? And of course, that will also tell you. You can set a threshold, and if the probability started going below that threshold, then you're going to stop and say, these are what I consider the key words that I'm depending on in the Gibbs model. Now, there comes the Bayesian model. How do I update the parameters? That's maximum likelihood estimators that I will get from parallel corpora when I have an expert translator that can give me information, or not just expert, one translator, but maybe a bunch of them. And this interaction could be in terms of, I am a translator, I will ask the translator, given this text, what is your sense of, give me a probability that this should be translated as this word versus another one versus another one. And the translator will say, well, in that text, based on just what I see, I would say 70% it should be this one, 20% it should be that one, and 10% would be the third possibilities. So I take that and then translate them into parameters of the gift distribution. And then take the parameter that I had before, plus the new parameter given by the translator, and combine them to get an update. So, and that's exactly what is done here. So let me. So, if this will be the maximum likelihood estimator based on the data, on the parallel corpora, and this guy will be the covariance associated with that maximum likelihood estimator. So and the prior is what the expert is giving me in terms of what they think the parameter should be. Of course, they don't give me that, they don't know Gibbs model, but I translate it into that. And if I take conjugate pairs, meaning the Gaussian in both, if that works, and do a map estimator where I get the maximum of the parameter given the data, what I end up with is a linear combination of the maximum likelihood estimator with the prior of the mean. And if the expert is 100% sure, that means the variance associated with the expert will be 0, which means that whatever data you give me, my update will be based on the expert totally. If, on the other hand, the expert is not 100% sure, there is a variance, then my overall or map estimator will be a combination. And if you give me more and more data, then the dependency will be more on the data than on the expert in the long run, meaning the maximum likelihood estimator will prevail. For finite data, for non-zero variance with the expert, it's a linear combination of both. Okay. Now that brings me to the third part, which is the relaxation when you have more than one ambiguous word in a sentence, and I want to disambiguate all of them at the same time. So let me look. So let's consider this sentence. Provisions address children's education to prevent the dropout problem. Here, there is education, provision, and address. They are ambiguous. They mean provision could be supplies, but also rules. Address could be I live in the States, or it address in terms of address the point. Right? So, and these are keywords, education and problem, that have only one meaning. So here you go. So I start by saying I'm going to consider provision and address flipping a coin. I'm going to flip a coin and start with initial. Provision will be supplies, address will be location. Then look at, if I fix location and try to change supplies into rules, is the likelihood going to increase? If it does, then I do the change. And then once I do that, I take supplies and make it rules, and then go back to location and see if I should change it into deal with. And I keep on doing this until the likelihood function doesn't increase anymore. But I'm doing it iteratively, so it's very easy to do. until I converge, and the convergence, the likelihood of rules with deal is 88%, and I cannot go more than that. So that means I have really converged to, if one can argue whether it's a local minimum or a global minimum, but I have converged. Now let's look at experiments, and in all of our experiments what we try to do is compare our method with the neural network and see how they fare. And we did that with the two sets of data. One is a medical data set, and the other one I would call literature data set. Of course, this one would be much easier, and you expect better performance than this guy. And we had a test bed of size 100, and we followed two different scenarios of how to, what we considered as the learning set and the test set. The leave one out is basically out of the 100. You take 99 at random, and you learn from it, and then you test on the one that is left, and then you repeat. Whereas the shuffle set, you take 50 at a time, and then you pick the first 80, you learn from it, and then you test it on 20. You would expect the performance of this one to be higher because the data set for the neural network in particular is larger. Whereas this one, you're testing it based on just 80, not on 99 and based on 1. So let's look at the performance for disambiguation using a second order clique. It's about 96 to 98 with our methods. With the neural network on the medical is also around an average of 97 to 10%. So they're about the same. Excuse me, this is up to a third order, whereas the neural network is 84% with a 0.06 variance or standard deviation. So for the limited data, the second order and the third order in the GIPS outperforms the neural network. But the neural network with 100 test bed is not that, it's 84. If you were to increase that to 300 or 500, this will jump over 90 right away. Okay. With the shuffle, it's even worse. It's 79, which is expected, because I'm learning only from 80 and tested it on 20 instead of learning from 99 and testing it on 1. And what is interesting here is that the maximum likelihood estimator with the GIPS is basically the same performance as before. It didn't change. With the literary fiction data, that becomes a different story. And now the clique order model and the GIPS gives you about 71% for second. But once you add the expert opinion, it jumps into 93. But then one would say, well, if you're going to add expert opinion, why don't you just go with the expert opinion period? And the answer is, of course, yeah, for that particular case. But if I gave you a different data set where you have learned from the expert, then it's going to be a different story. The importance here is that with the neural network is about 65. So you compare 93 with the expert opinion with 65. But to be fair, the expert opinion was not somehow translated with the neural network. So maybe you can compare the 71% to 65%. With the shuffle is about, again, the same 70%, 93% for our method, and this one goes even down, 60%. So to come up to summarize, we have introduced a Markov-Gibbs model, which has commonality with the trigram, but is also different and more general. We were able to induce or have the expert translator coming into the loop. to be able to update the Gibbs model to give me more, a better translation. Bear in mind that also the trigram and the Gibbs model are based on different graphs. One is on proximity graph, the other one is on semantic graph. And then we also introduced the iterative relaxation, a quick way of disambiguate sentences which have more than one word, which can assume more than one meaning. So in conclusion, I would say until human or machine translators become sensitive to culture and understanding of what is written or spoken, translation will remain a mechanism that reinforces pre-existing stereotype, misconception, and misreading in defining the other. And I would say there are 2 papers in this conference. One deals with the opinion, extraction of opinions in news, where there is a lot of bias against Middle East and Islam in particular, as well as one in plagiarism that also talk about how you, in Arabic, how you can pick up plagiarized translation. So with that, I will add this all feed into this cultural understanding, basically, and one should really invest a lot of efforts in making sure that that side of translation is taken care of, however difficult it is. So with that, I will conclude, and the platform is yours.
Thank you. Thank you very much, Professor Cohen, for this interesting talk. Now we switch to question. If you have any question. Yeah.
Yes.
Excuse me, my name is Samir Bashi. I'm a professor at Cohen University. I have, as you know, the machine translation is not easy.
No, it
It's
isn't.
very difficult.
Yes.
And my question is about your translation method. Is it generic, which means can we apply it for any language in the domain? Otherwise, how can we make it generic?
No, it is generic. So I have 2 groups of students. One is from mainland China, and all the examples they used are Chinese. And I have another group from the Middle East, and of course all the examples that they're used with the Jalabiya, for instance, are Arabic. So basically the idea of keywords could be in any language in terms of the culture that is embedded in that keyword. So I would say yes, it is generic in that sense, but one of the problems that you have is that you don't have too many parallel corpora that you could use, and hence the problem becomes of is the data available rather than is the method generic or is it not. So that understanding is very important, and that you will not get by just having a good linguist. You have to have more than that.
I agree with you, but linguistic methods, they not only cover syntactic analysis, but also semantic and context.
Yeah, but once they do that, then cultural, once you talk about semantics, there is a culture associated with that. And if you do semantics with that as a background, then I totally agree. Okay, you are.
Other question? Yeah.
Yes.
Thank you so much for this talk. I have a question about your model.
Yes.
I think you consider only distribution model, Gaussian model. Have you tested all our models such as multinomial or Poisson or other models?
No, actually the model is not Gaussian.
No,
What?
not Gaussian?
No, it's not Gaussian.
Okay.
It's a Gibbs model. Belongs to the exponential family, but it's not
Okay.
Gaussian.
Okay.
Yes. The Gaussian, the normality assumption comes in when I estimate the maximum likelihood estimator, because maximum likelihood estimator for large set is Gaussian. So that's how the normality came about. But it is not Gaussian, no.
I have another question
Sure.
about work embedding. I have seen that you have discussed about sense to vector. What is the difference between work to vector and sense to vector?
I'm not getting the question, so.
I have seen in your slide,
Yes.
globe, in the northern network, we have globe, work to make, and sense to make. What is the difference between sense to make and work to make?
What is sense to make?
I have
Yeah,
seen in your slide.
let me get the slides and tell me which one.
Yeah.
Okay, thank
The
you.
third slide, maybe.
Oh, the third slide.
Maybe.
Maybe.
Maybe. Allahu Alam.
No, that's not good. Let me go to the beginning.
In the beginning, yes.
After.
After.
Tell me when to stop.
No, before.
Oh, it's before the
I
model?
don't see before. When we have no globe, yes. This neural network, you have globe. And
Oh, Globe is the author
and
of that paper.
sense to vector. I think I see sense to vector. Je vois pas très bien ici.
Oui, sense to vec.
Yes. What is the difference between sense to vec and work to vec?
To tell you the truth, I don't remember.
Okay.
There are differences, but I don't think there are
I think there
that.
is a difference. Right?
Yeah, sorry about that.
Okay.
Okay.
Other question?
What is the computational complexity of the
For estimating it's
estimation of the parameters?
it's not for the model that we use, which will give you the log of its frequency of occurrence. So that's not bad. But it depends on. If I give you a book, it's very different than give you a chapter. It's very different than I give you a paragraph, right?
Yes.
But all, the importance is that there is a lot of offline learning that you do, right, with the estimation of the parameters before you come to the point of classification. So the classification should not be terribly bad, because first of all, in a sentence, how many words are ambiguous? Ambiguous word. I should add that the use of the translators add ambiguity where it was not. Meaning, so you open the dictionary in the English language and you look at one word and it has, let's say, one and only one meaning. But now I start playing with the words, and then have different a subtext to what I intend to say, and therefore an expert should add that ambiguous interpretation of the word, so that next time around I don't go automatically and assign it one thing.
Thank you.
Yes.
I have one general question.
Sure.
How can we measure the accuracy of the machine translation system? Because I think that there is not a single correct translation.
Mm-hmm.
If I give one paragraph.
Yes, I hear you. I hear you.
So how can we?
Okay, so my answer to that is, in medical imaging, in the medical community, we have biopsy. So in other words, if I want to know whether a procedure that I am developing for cancer detection is good or not, all I do is I have biopsy that will tell you, which is the gold standard, that will tell me whether or not. So in translation, how do I get to that? And my answer would be, you get the most respectable translators in the field and have like like zoom on what they are agreeing on and consider that as the gold standard. That's the only thing you could do. So if for instance, like I'm doing translation from Arabic literature to the English literature, there are big names, translators, that have been working in that field forever, right? So I go and say, all right, you gave me, how would you translate this sentence? I go to expert number 2, expert number 3, etc., and then form a consensus, and that consensus will be the one that I will compare machine translation to. Other than that, there is nothing you could do. So you have to go to an expert translator as the gold standard or the average of expert translators.
So in your opinion, how long it will take for technology to approach the human performance?
Well, the thing is, it depends on the human. So, so if you're talking about a human that is biased, that has stereotypical idea of a region, that is not, I don't want the machine to be like that. So I want the machine to really mimic what in the field of translation, of human translation, will agree that this is really a fantastic expert. Otherwise, no, I don't want it. So, and I would like to give you an analogy also with the machine. And I do a lot of work in biomedical imaging for cancer detection. And one of the projects that I was involved in was in early cancer detection of breast cancer using ultrasound. Now, ultrasound as a modality, in terms of having a radiologist looking at it and seeing pre-cancer cases, is very mediocre. Why? Because they can't see it. There is the speckle field, and you can't see what's going on at the millimeter level. So do I want a machine to mimic the radiologist? Absolutely not, because it's going to give me exactly the same kind of non-committal answer, which is I don't see it unless it's so progressive that it's stage 3 or stage 4, which is useless in this case. So that comes back to the same answer that I gave you. I want the machine to mimic good translators. And I'm not, of course, I'm not in linguistics, I'm an engineer. So there are people who are in that field that will tell you who are the good translators and why. And then try the machine to mimic that. Okay? Yes. Comme vous voulez, mais c'est marocain, alors algérien, c'est même pur.
Pour l'approche statistique, normalement, il y a plusieurs problèmes pour l'approche statistique pour des raisons. Le corpus, normalement, n'est pas exhaustif. Les gens qui réalisent, bien qui normalement ne sont pas des spécialistes, normalement, au lieu de créer des corpus, on doit créer des dictionnaires et des grammaires. Pourquoi on utilise toujours, jusqu'à maintenant, l'approche statistique? Normalement, dans votre exposé, Cultural Translation, normalement, pour l'expérimentation, vous avez cité un domaine d'application. Donc, à quoi sert le culturel, sachant qu'on a précisé un domaine d'application. Normalement, lorsqu'on fait un domaine de la médecine, ou bien la traduction dans le domaine de médecine, donc c'est-à-dire qu'on a un dictionnaire spécifique, les mots, etc. Donc, pourquoi on doit parler sur culturel?
C'est plus difficile. It's much more complicated, and for good reasons. And actually, the way we're approaching it is we're doing that by instilling in the learning process, in creating those dictionary that you're talking about, those cultural experts. So you see how I start. First, you start with parallel corpora, right? This is what's and what you're saying is absolutely correct. I mean, it could be garbage, right? But I have to depend on it first. Then I would say I get experts to instill their opinion, good experts to instill their opinion, and update these parameters, i.e., I'm updating those corpora to think about that. Are you good?
Okay.
Yes.
Je peux rajouter quelque chose. Il ne faut pas mettre l'approche statistique en confrontation avec l'approche linguistique. On peut combiner les deux. On peut combiner les deux, c'est mieux. We can combine.
Absolutely. Yeah. But I mean, neural network.
La régularisation en faisant de l'approche statistique avec l'approche sémantique.
Yes.
Maybe be the studies of history, of history topics in the same language, also have a very impact of cultural situations and to understand. The question is which distance it's possible.
The only problem I have with that is that we as humans do not learn from history, unfortunately. We'll keep on repeating the same mistakes. But yes, yeah, absolutely. Okay, yes.
I hope to know what is if there is difficulty to translate from to Arabic script or Persian script, in such as what is difficulty to study the non-Roman script or the classical translation.
So if I understand you correctly, you're saying when translating from Romantic language to Arabic.
Recursive language.
Excuse me?
It's basically he's asking about the recursive language, like the same question I'm going to ask. Like we speak Urdu is written like Arabic.
Yes, so to that, yeah.
That's
so
the problem actually.
I would say the minute you have different slang and different dialects going into a language, the more challenging it is, and the challenge will not be as challenging the minute you incorporate that difference. So if I look at even in Egypt, if you go to the south of Egypt, there is Saidi Egyptian, and then there is the Cairo Egyptian. And sometimes I have difficulty understanding what this is saying. But if I'm a good translator, I would live in there and try to pick up what the differences are, what they mean. And then it's not going to be a challenge anymore because I'm incorporating those differences in. If I don't, then I'm doomed. So your success, again, is very much correlated with your understanding of what you're translating. The less understanding you have, the worse it's going to be. And the more understanding, the better it's going to be. Is it an easy thing to do? No, it isn't. That's why we need you all.
Okay. Okay, thank you.
Yes.
I have a question. I have a difficulty to understand how the machine selects ambiguous words. It considers that all the words at in the beginning are all ambiguous, or there is a method to select them?
Okay, so in the experiment we did, or in general?
In general.
In general, yeah. I mean, in general, what you would like at the end of the day, you take a book, you put it in that machine, it spits it out, translate it.
Yeah.
Is that, are we there? Absolutely not. So what we do, and what we did in our experiment, is pick what are the words that have more than one meaning.
By
And that's
you?
what, yeah, by you, yeah. The students went in,
Yeah.
labeled it.
Okay, not a specialist in domain, in the field. My question, it is possible to give some meaning of score of different model. For example,
I would say, I would take this and put it into what do they do in a successful field like medical imaging?
yeah.
Or what they do is you have to run it on the same test beds. So you have a test bed that everybody knows what is a good, they have a gold standard, and then you come in with your method, I come in with my method, work it on the same test bed and compare the results. That's the only way I could see it.
But it is possible in general for different, for example, different domain. For each domain, you have.
Oh yes, so you mean for being more specific?
Yeah.
The more, the way I will answer this, the more a priori knowledge you have about the domain, the less, the better you are.
Yeah.
So it depends. So again, it fits into the same thing that I said. If you understand what's going on, you're going to do a good job. If not, you're not.
Okay, thank you very much for your existing